Hello. Hello, everyone. Good morning to all. So today I will discuss about the normal distribution problem. Normal distribution problem. So first of all, we discuss what is the normal distribution problem. A normal distribution problem, which is also called the Gauss distribution problem. The normal distribution problem, the other name is called as the Gauss distribution problem. That is Gauss distribution problem. Gauss distribution problem. Normal distribution problem is also called as the Gauss distribution problem, and it is continuous distribution. It is a continuous distribution problem. It is a continuous distribution problem. It is a continuous distribution problem. Normal distribution is a continuous distribution problem, whatever we have discussed. And the probability density function of normal distribution is defined as the probability distribution function. The probability distribution function defined as what is the probability distribution function? We can define that is a function fx, and I have written here 1 by sigma root over of 2 pi. Sigma root over of 2 pi e to the power minus 1 by 2 x minus mu whole square by sigma. X minus mu by sigma whole square. For sigma is positive, the range value of x minus infinity less than x is less than infinity, and mean also minus infinity less than x less than infinity. But sigma is the positive value. So the probability distribution function defined here, fx is equal to 1 by sigma root over of 2 pi e to the power minus 1 by 2 x minus mu by sigma whole square. Where here mu is represented as the mean. Where you define this is mean, and this is standard deviation. Sigma square is the variance of the normal distribution. Variance of the normal distribution. So you can say that sigma square is variance of the normal distribution, which is the positive value, and x is the random variable which lies in the interval minus infinity to infinity. And mean also, that is the range is defined here minus infinity to infinity the mean. So that some conditions I have also expressed here for the normal distribution functions. Mu is the mean and first point. Mu, that is mean, and sigma, that is standard deviations. Standard deviation of the problem. Just remember here, mu is the mean and sigma is the standard deviation of this problem. And 1 by 2 pi, root over here be 1 thing remember, 1 by sigma root over 2 pi. is a constant factor. Is a constant factor. Remember here 1 by sigma root over 2 pi is a constant factor. Makes the area under the curve, makes the area under the curve of function f of x, and which is equal to within the limiting value with minus infinity to infinity is 1. Area under the curve of this function is equal to 1. This is as the specific property of this function. So function fx, which is the decreases rapidly at x is equal to plus minus infinity of the curve. So that the curve f of x symmetric about. So that is, we have to discuss about the mean normal distribution of the function. Here we have to discuss this one is the normal distribution of the functions. And curve of the fx is symmetric. The one thing we remember here, curve, normal distribution function, curve of the normal distribution function. The curve of the normal distribution function what is the curve of the normal distribution functions? The curve of the normal distribution function here is mentioned. Or other distribution name is that one is the Gaussian normal distribution function, and just x is equal to 0, and that is also mean. We have to say that. So what is the property of this graph? Actually, we have to mention here y is equal to f of x be a function. It's called the bell-shaped curve. This one you can see, this is the bell-shaped curve. It is a function. We consider this point. It is a bell-shaped curve. Bell-shaped curve. So just you see the structure of curve is bell-shaped, or of the bell-shaped curve of the normal probability curve. The curve is symmetric about mean. Second point, curve is symmetric about mean. This is first point, this is second point. The curve is symmetric. Symmetric about mean. So just remember, here the curve is represented here, and that curve is symmetric about the mean here. And mean is represented here. See, this is the mean, and this curve is symmetric about this mean. 0.68. The curve is symmetric about mean. The maximum occurs at mean. The maximum value 0.3. Maximum value occurs at mean. The maximum occurs at mean. The maximum opposite mean, that is mu, maximum opposite mean, and maximum value is maximum value is 1 by sigma root over of 2 pi. This is maximum value at mean. This is the maximum value. Maximum value of course at mean, and the value is 1 by sigma root over of 2 pi. This is the maximum value of course at this mean. Just remember maximum value where is of course in this place. This is the place where maximum value is of course, and this value is 1 by sigma root over of 2 pi is there, and this is the place of maximum value, and this is the maximum point of this value, right? 1 by sigma root over of 2 pi. Maximum value of course are this. Point 4. Point 4 is that the ordinate fx decreases rapidly. The ordinate fx decreases rapidly. The ordinate fx decreases rapidly as x tends to plus minus infinity. Just we can see the ordinate fx is decreases rapidly when x is tends to plus minus infinity. And x-axis is asymptote. And x-axis is asymptote. This is x-axis represented here, and that is the, we say that is asymptote. X-axis are the asymptotes. Again, x is asymptote of the curve. The point 5, the graph is concave downward at x is equal to mu. The graph is concave. Concave downward at mean at x is equal to mu. Concave downward at x is equal to mu. And concave upward at x is large. And concave upward at x is large. If x large होगा तो that is concave upward होगा. The graph is concave downward at x is equal to mean, and concave upward when x is large, very wide. When x is large, this is the upward. The concavity changes at the point of inflection. The concavity changes at the point of inflections. The concavity changes at the point of inflection given that by the solutions on y double dash equal to g, y double dash of x is equal to 0. That's the point of inflection it changes. These points are given by x is equal to concave changes are the points x is equal to mu plus minus delta. Sorry, mu is equal to x plus minus delta. X concave changes at this point and double derivative of x is equal to 0 and x is equal to mu plus minus delta, then function changes. If delta is large होगा तो क्या होगा? What is delta is large? The current trends, the current curve tends to flat. If delta large, then curve tends to flat. ये large होगा तो this is flat. If delta tends to small, then curve tends to more peaked at mean. Tends to more peak. At mean. The curve tends to more peak at the mean. These are the points of the event. Now I am just divide the distribution function of normal distribution function. Distribution function of normal distribution. Okay. So we will discuss now distribution function of normal. Okay, we will discuss distribution functions next time. Okay. Thank you to all.